This video outlines how to connect 8 Class C networks to each other and link to an outside network via 3 routers. The 8 Class C networks to be set up are shown here, along with a single Class A/29 subnet for inter-router connection. Select the Routers option. Then find the PT Empty Router option. Add a router to the work area. Click on the router to open its settings window. Turn it off by clicking on the power switch. You now need to add physical ports. These are listed in the left pane. There are 4 LAN ports to choose from. UTP Copper Fast Ethernet. Note the details in the lower panel. UTP Copper Gigabit Ethernet. Fiber Fast Ethernet. And Fiber Gigabit Ethernet. Click and drag the Copper Gigabit Ethernet option over to the right-hand port. Repeat this so you have 5 ports. It is good practice to cover empty ports, so this is the next task. Select the cover from the options and cover the remaining ports. Now turn the router back on. This will act as a template for the 3 routers. Note that as this is a simulator, the router will take time to restart. You can change the name of the router as done here. You can make a copy of the router by selecting it, use Ctrl+C to copy it, and Ctrl+V to paste a copy. Alternatively, you can use the Edit menu's copy, followed by its paste option. Do this to add 2 more routers. Position and rename them as desired to aid identification. Note that you can also rename the router through its window. Click on the router and select the Config tab. Change the name as desired. The 3 routers are ready for physical connections to switches via UTP cables. To simplify the interconnection of the 3 routers, a switch is to be added. Select the Switches Items option. Then add a PT Empty switch. Rename the switch to your desired name. Open the switches window. Turn the switch off so you can add the physical ports you need. The key option is the UTP Copper Gigabit Ethernet, as this is the type fitted to the routers. Add 3 ports to the switch. Now, for correctness, add covers to the other ports. Restart the switch. This takes time, however you can speed up time by using the highlighted icon. Select the Connections option. Then select the Copper Straight-Through connector. Connect one end to the Gigabit Ethernet 0/0 connector of the main router. Connect the other end to the Gigabit Ethernet 0/1 connector of the switch. Repeat the process to connect the other 2 routers to the switch. Connect one end to the Gigabit Ethernet 0/0 connector of the first router. Connect the other end to the Gigabit Ethernet 1/1 connector of the switch. Next, connect one end to the Gigabit Ethernet 0/0 connector of the second router. and the other end to the Gigabit Ethernet 2/1 connector of the switch. The physical connections for the 3 routers and main switch are now complete. Return to the Switches option section and add 8 of the 2960 switches. These 24-port fast Ethernet switches are ideal for testing connectivity. You can use copy and paste to add the remaining switches, or simply drag them from the options section as shown here. You can now connect the switches to the routers. Use straight-through copper cable. Connect a switch 1 gigabit port to router 1's gigabit Ethernet 1/0 port. Connect router 1's gigabit Ethernet 2/0 port to a gigabit port on switch 2. Gigabit Ethernet 3/0 port to a gigabit port on switch 3, and finally, gigabit Ethernet 4/0 port to a gigabit port on switch 4. Now for the second router. Connect router 2's gigabit Ethernet 1/0 port to a gigabit port on switch 5. Gigabit Ethernet 2/0 port to a gigabit port on switch 6. Gigabit Ethernet 3/0 port to a gigabit port on switch 7. And finally, gigabit Ethernet 4/0 port to a gigabit port on switch 8. The physical layer to the network switches is complete. Select the End Devices option and drag 9 PCs to the work area, as shown. Delete the PC labeled PC0 by using the delete icon and clicking on the PC. Cancel the delete tool by clicking on the select icon. Reposition the PCs as desired. You can now connect the PCs to their switches. Use straight-through copper cable. Use the fast Ethernet ports of the PCs and any fast Ethernet port of the switches. Switch fast Ethernet port 0/1 is used here on each switch, for ease of monitoring the network configuration later. All network cabling for layers 1 and 2 is complete. If using indicators, then your design should look like this. The red indicates that the router ports have not been switched on yet. This will be done during the IP configuration stage. To set the main router, click on it to open its configuration window. Select the Gigabit Ethernet 0/0 interface. Add the IP configuration of 10.0.0.3 with the subnet mask 255.255.255.248. Turn the port on. Close the router's window. Note that the link now shows green. Open the first router's window. Select the Config tab and select the Gigabit Ethernet 0/0 port. Add the IP configuration of 10.0.0.1 with the subnet mask 255.255.255.248. Turn the port on. Select the Gigabit Ethernet 1/0 port. Add the IP configuration of 192.168.1.1 with the default subnet mask 255.255.255.0. Turn the port on. Select the Gigabit Ethernet 2/0 port. Add the IP configuration of 192.168.2.1 with the default subnet mask 255.255.255.0. Turn the port on. Select the Gigabit Ethernet 3/0 port. Add the IP configuration of 192.168.3.1 with the default subnet. Turn the port on. Select the Gigabit Ethernet 4/0 port. Add the IP configuration of 192.168.4.1 with the default subnet. Turn the port on. Close the window. Open the second router's window. In the Config tab, select the Gigabit Ethernet 0/0 port. Add the IP configuration of 10.0.0.2 with the default subnet mask 255.255.255.248. Turn the port on. Select the Gigabit Ethernet 1/0 port. Add the IP configuration of 192.168.5.1 with the default subnet mask. Turn the port on. Select the Gigabit Ethernet 2/0 port. Add the IP configuration of 192.168.6.1 with the default subnet mask and turn it on. Select the Gigabit Ethernet 3/0 port. Add the IP configuration of 192.168.7.1 with the default subnet and turn it on. Select the Gigabit Ethernet 4/0 port. Add the IP configuration of 192.168.8.1 with the default subnet, and turn the port on. Close the window. The router ports are now configured with IP addresses, and as they are turned on, the Layer 2 links from them to the switches show as green arrows. Setting the IP addresses of the PCs should be done through their respective Windows Desktop tab and using the IP configuration option. Access the IP config section for PC1. Set the static address to 192.168.1.254 with the default subnet mask. Set the default gateway to Network 1's router address, 192.168.1.1. Close the Configuration tab, then close PC1's window. Repeat for PC2. Set the static address to 192.168.2.254 with the default subnet mask. Set the default gateway to Network 2's router address, 192.168.2.1. Close PC2's window. Repeat for PC3. Set the static address to 192.168.3.254 with the default subnet mask. Set the default gateway to Network 3's router address, 192.168.3.1. Close PC3's window. Repeat for PC4. Set the static address to 192.168.4.254 with the default subnet mask. Set the default gateway to Network 4's router address, 192.168.4.1. Close PC4's window. Repeat for PC5. Set the static address to 192.168.5.254 with the default subnet mask. Set the default gateway to Network 5's router address, 192.168.5.1. Close PC 5's window. Repeat for PC 6. Set the static address to 192.168.6.254 with the default subnet mask. Set the default gateway to Network 6's router address, 192.168.6.1. Close PC 6's window. Repeat for PC 7. Set the static address to 192.168.7.254 with the default subnet mask. Set the default gateway to Network 7's router address, 192.168.7.1. Close PC 7's window. Repeat for PC 8. Set the static address to 192.168.8.254 with the default subnet mask. Set the default gateway to Network 8's router address, 192.168.8.1. Close PC 8's window. In order to allow inter-routing communication, their RIP, Routing Information Protocol, data must be set. This simply means adding the network addresses of the networks on their ports. One complication is to set RIP to version 2, which means using the CLI, as you will see. Access the main routers window. On the Config tab, select the RIP option. Enter the inter-router network, 10.0.0.0 address. Then click on the Add button. The network should be visible in the list. To set RIP to version 2, open the CLI tab. After the prompt, router, config router, hash, add the text version 2 and press enter. Version 2 is set. Close the routers window. Access the first routers window. On the Config tab, select the RIP option. Enter the inter-router network, 10.0.0.0 address, then click Add. Repeat for the first network, 192.168.1.0 address. Repeat for the second network, 192.168.2.0 address. Repeat for the third network, 192.168.3.0 address. Finally repeat for the fourth network, 192.168.4.0 address. To set RIP to version 2, open the CLI tab. After the prompt, add the text version 2 and press enter. Version 2 is set. Close the routers window. Access the second routers window. On the Config tab, select the RIP option. Add the inter-router network, 10.0.0.0 address. Repeat for the fifth network, 192.168.5.0 address. Repeat for the sixth network, 192.168.6.0 address. Repeat for the seventh network, 192.168.7.0 address. Finally repeat for the eighth network, 192.168.8.0 address. To set RIP to version 2, open the CLI tab. After the prompt, add the text version 2 and press enter. Version 2 is set. Close the routers window. The system is now configured, as shown when moving the mouse over the three routers. You should see the router ports are up and have their IP addresses set as per the design. testing is best carried out using the PC's command prompt and ping. The prompt can be found on the PC's desktop. You should test each PC to ensure it is correctly configured and the routers have good intra-router network connections. Example 1. A test ping from PC1's prompt 192.168.1.254 to PC2 192.168.2.254. Note that the first ping times out. This is expected as the switches will not have complete MAC address tables, so initial frames will get lost. However, PC1 should receive replies within the first 4 packets sent. Example 2. Testing the link from PC1 to PC5, which is via both routers, to test the intra-router connection along with the PC configurations. Note that the first 2 pings time out before a good reply is received. Example 3. Testing the route from PC1 to PC8, using Tracert, to see which routers are involved. Note how the IP addresses of the first router and the second router are listed in the steps taken to communicate with the target PC on network 8. It is always a good idea to save changes to the router's configuration, so a reboot does not clear your settings. Open the Config tab of the main router's window and click on the NVRAM Save button. Then close the window. Repeat this for the 2 other routers. Now, if you reboot a router, you will not lose its settings. This completes the activity.